Hey, welcome back. We're going to work a few log properties, and we're going to start with 3 problems where you're asked to expand a logarithm using properties. So let's take a look at number 1. Log x squared y. Now notice there's no base here. It doesn't say log base something. So when there is no base, you assume it's a 10. So technically, this is log base 10, x squared times y. So what you need to do first is split up your x and y. You can't deal with that squared until you've separated the logs. So what we're going to do first is rewrite this as log x squared, and because the arguments are being multiplied, we can rewrite this as an addition problem. So plus log y. Now you're almost done. Now you need to get rid of the exponent and turn it into a coefficient. So if you remember from our previous video, the power moves in front and becomes a coefficient. So now we have 2 log x plus log y. And now you've expanded the log as much as possible. Let's take a look at the second one, log x divided by yz. So you have 3 variables, which means I'm going to have 3 logs. But before you can split anything up, you got to get rid of the division. So we're going to rewrite that as log x minus log y times z. So the first thing we did was split up the division into a subtraction problem. Now you're almost done. To expand means you can't have anything being multiplied anymore. So we need to break up the log yz. We're going to leave log x the way it is. And then log yz, because they're being multiplied, becomes log y plus log z. Now we've expanded it completely, where x, y, and z are their own individual logs. Let's take a look at number 3. Log x times the square root of z. All right, well, we'll deal with that square root, but before we do, let's go ahead and split up this multiplication. So we're going to have log x plus log times the square root of z. Now you might be thinking there's nothing wrong with the square root of z, but as we learned yesterday, the square root is another way of writing a fractional exponent. So whenever you have a square root, you actually have an exponent. And if you have an exponent, you need to move it. So we're going to rewrite the square root of z as z to the 1/2 power. Now I have an exponent, and I can move that exponent, and it can go in front of our log. So we have log x plus 1/2 log z. That's our final log. Now let's do the opposite. Instead of expanding, we're going to condense. So we're going to use all the properties, but in reverse. Let's take a look at number 4. 3 log x plus 2 log y minus log z. Now in the last examples, when we're expanding, the exponent was the last thing that moved. When you're condensing, it's the first thing that moves. So what I'm going to do first is move all of these coefficients and turn them into exponents. So this becomes log x to the 3rd power plus log y squared and then minus log z. Now when you're condensing, you can only condense 2 logs at a time. So we're going to do the first 2 that we come to and condense those. They're being added, so we're going to multiply the arguments. Log x to the 3rd y squared, and then we have minus log z. Now we can condense these logs again into a single logarithm. And here we're going to have log. Now order matters. The first log goes in the numerator, and the second log goes in the denominator. So we're going to have log x cubed y squared divided by z. And that's our final answer. So we went from 3 separate logs to a single logarithm. Okay, let's look at number 5. 2 log x minus 2 log y. You have coefficients, so the first thing you're going to do is rewrite those coefficients as powers, and you now have log x squared minus log y squared, and then we can rewrite these logs into a single logarithm by condensing it as log x squared over y squared. Now, you could go a step further on this one. Since the x and y are both being raised to the second power, you could rewrite this as log x over y quantity squared. Either one of those is a valid answer. Just depends on what you're looking for. Okay, let's look at number 6. Similar to number 5, you have coefficients. So the first thing you're going to do is move those coefficients so that they become exponents. We have log x to the 1/3 power plus log y to the 1/3 power. The logs are being added, so we will multiply the arguments. We have log x to the 1/3, y to the 1/3. Now, if you remember the last example that we did on the previous page, problem 3, where we had the square root of y, and we rewrote that as y to the 1/2 power. When you have a fractional exponent, you are expected to rewrite that as a root, as a square root or cube root, whichever one you need. So what I'm going to do is the same thing we did above and rewrite this as x times y raised to the 1/3 power. Just makes everything a little bit more clean, a little bit more easy to work with. And now I'll get rid of the fractional exponent by writing this as log the cube root of x times y. And I can only do that because everything is being raised to the 1/3 power. And the 1/3 power is the same as a cube root. Hope this helps you all out.